Hello everybody. Welcome back to our session on Python programming. We're discussing concept of functions. In the last session, we talked about local and global variables. Today, we plan to talk about a very important or a very special type of function called as recursive function. So let's understand what exactly the recursive functions are all about. So Python does have a support for recursive function. What is a recursive function? A function that calls themselves. So if there is a function which gives a call to itself, till now we have been having functions which are calling some other functions. But at any point of time, it so happens the function gives a call to itself, either directly or indirectly. Now, what do you mean by directly or indirectly? I'll discuss with the help of an example in order to loop. So you can think about a recursive function as an alternative for using loops. So a lot of places you can actually eliminate the loops by using a recursive function. The examples that I'm going to take will also focus on the same aspect of recursive function. Now there is a word of caution over here. Today the examples I'm going to take are only going to demonstrate how recursions are to be used, are not the best cases for which you should use recursion. You will ask me, then why am I taking those examples? My objective over here initially will be to enable you to understand how recursion works so that you could use it. I'll later tell you which is the best time to use recursion. Please do not use recursion for the kind of scenarios which examples I'll take right now. If the recursion brings about substantial reduction in size of the code, then you can think about recursion. And if it's not going to bring about substantial reduction in size and complexity of the code, we should avoid using recursion. So examples that I'll take, the number of lines of code that you will be writing are almost the same for recursive as well as non-recursive code. In those cases, recursive functions are just not recommended. But I'm going to take the simplest examples so that you understand this concept. So tomorrow later, when you write some complex applications, there if it is required, you will know how to use it. Recursion is even an alternative to simple loops and iteration, though not necessarily the simplest and the most efficient one. So that's what I'm saying. It's not more the most simplest, neither the most efficient one. When you talk about efficiency, is far more inefficient than your non-recursive function. Why is it? I'll help you with the help of an example. A recursive call to a function should always be made with a conditional block in the function definition. Now, all these statements are true for any programming language. I almost always start with the discussion of recursion on all the same note. So if I'm going to make a recursive call to a function, that means within a function, we are going to give a call to itself that should always be made within a conditional block. That means there will be some if condition, and if the condition is satisfied, only then we'll make a call. Now you may be wondering, why should we do so? The reason for doing so is like, there has to be some point in time where that condition becomes false and it stops making recursive call. Otherwise, it will become an infinite loop. So like in a looping constructs while loop, we have a condition that becomes false at some point of time. Whenever in loop, the condition becomes false, the loop terminates. So if I directly give a recursive call, it will be like an infinite loop. It will just keep on repeating again and again. So we have to control when the recursion should stop. And that is what we do by putting a conditional statement. But there are two types of recursion we said here. I said directly or indirectly. Now, what do you mean by indirect recursion? So indirect recursion doesn't fit into the definition where the function does not call itself directly, but definitely indirectly. How? Say there is a function A. This function A gives a call to function B. If you watch it, this function A gives a call to function B. Control comes here. Function B gives a call to function C. Control comes here. Function C gives a call to function D. Control goes here. And function D gives a call to function A. Control goes over here. So what is happening? It's an indirect recursion. So although not directly, but indirectly, you're making a recursive call. So although A is not calling itself, A calls B, B calls C, C calls D, and D calls A. So indirectly, it becomes a recursive call. So that this is an indirect recursion that you may come across. But what we are going to focus is more on direct recursion. What is direct recursion? A function can call itself. So there's a statement within a function which gives a call to itself. The function can call itself and a function that contains a call to itself is referred to as a recursive function. First, every function has a permission to call itself. It has a permission if it wants to, but if it does so, we'll call it as a recursion. So there is a function f, and somewhere inside the function, it gives a call to itself. That obviously has to be done within a conditional block. But even if you don't do within a conditional block, it's still a recursive function. Data is organized as a tree. Data organized as a tree can be traversed effectively using recursion. Now, this statement I have made because all these years, the best example that I have seen that we can discuss during academics is a recursive call to traverse through a tree structure. Now, what is a tree? A tree is like a regular tree where there are branches and there are subtrees and so on. So function for accessing the items in a tree can simply call itself when the branch node is encountered. Suppose you have such a tree where A is the root. In data structures, tree is something like upside down tree, root at the top and the leaves at the bottom. So from A I want to go to B, I want to go to D. Then how do I come to E? How do I go to this? So this tree data structure, if I have to traverse recursively, which you'll learn in data structures later, the best form that is available is our best code or the most easiest code to implement and to understand, because one of the quality based on which property based on which we decide the quality of the code is it's how easy it is to understand. So sometimes it so happens a recursive code becomes very easy to understand. The best example that comes to my mind is this tree data structure, which when we have to traverse, the recursive code is the easiest and the best way to implement and also to understand, unless the depth of the tree is not very high. That means the levels that are there inside this tree is not like 1,000 levels or more than 1,000 levels. If it is not so, recursion is the best way to go ahead. Now look at this. I have a function called as main. Here I say eval, and then I give a call to function factorial. Now when I come to factorial, note there is no loop over here. Within a function factorial, there's a statement which gives a call to itself. Now when we do so, it becomes a recursive function. That means if I pass value of n as 4, let's take a very simpler example rather than talking about this, and then we'll go to recursion versus iteration. We say recursion is an alternate form of a program control. It essentially is repetition without loop. So you want to repeat some statements for n number of times, and you do not want to use loops, you can think about recursion. A recursive program can run out of memory, causing stack overflow exception. This is what I'll demonstrate, how the program crashes. To avoid using recursion, if you are concerned about program's performance, when I said in the beginning, recursion are not the most efficient way to write the code. Why? Because the amount of memory that they utilize is very high, because they consume more time and consumes more memory than iteration. And I'll show you with some examples. What we'll be doing is, I'll be explaining this syntax first, how to design such a function, and then later I'll show you the impact on the memory as well. It could be an approximation, because what we'll be doing is like we'll be taking up some visualizers for Python just to demonstrate how much more memory it utilizes. So let's jump onto a function first, an example where we see how recursion really works. And to give a demonstration to see the memory impact in the memory, I'll keep open the visualizer. So let me also, till the time the spider starts, let me also open up the visualizer. So any visualizer you can take, whichever comes first, that doesn't really matter. Oh, that's not very good. I want to have a larger code. Okay, this could be good enough. And latest version that there is 3.6. That's good. Okay. Okay for us. 3.6 is okay. And let's meanwhile check out our code. Let me take the simplest examples first. Then I'll tell you about the performance as well. My favorite example to explain anybody concept of recursion. Again, I'm repeating myself. These are not the best kind of scenarios for which you should think about using recursion. These are only the best example to understand how recursion works. So look at this code only with the intention of understanding how recursion really works, not with the intent to understand or not with the intent of using it, okay, for this kind of purpose. The first example that I'm going to take is a function called as print ascending. Now, what does this print ascending function do? I wonder why is it not collapsing? I want to hide certain things from you. Oh, it's there. Let's not look at the code. So that let's focus only on the code of our interest. This is a non-recursive function. I could have used a for loop to print the numbers in ascending order, or I could use a while loop. Say I decide to use while loop. I say for user passes a limit. I take a counter whose value is 1. I say while counter is equal to limit. Assume that user passes value 5. So counter is 1. 1 less equal to 5 hai kya? Yes. We print 1. Counter becomes 2. 2 less equal to 5 hai kya? Yes. We print 2. Counter becomes 3. 3 less equal to 5 hai kya? Yes. We print 3. It becomes 4. 4 less equal to 5 hai kya? Yes. Yes. So it prints 4. It becomes 5. 5 less equal to 5 hai kya? Yes. It prints 5. It becomes 6. 6 less equal to 5 hai kya? False. We return. So that's how this particular function is working. So let's run this particular code and also we'll debug the code. I enter number as 5. You got numbers in ascending order like 1, 2, 3, 4, 5, and so on. Okay. So let's debug this code. Watch it very carefully. We are here and I run this particular code rather than debugging this code. I have been asked to enter the number. I enter number like 5 once again. Say control will now go to that function. Let's debug it once again. I've been asked to enter the number. I enter number 5. We are at line number 50. We give a call to that function. Control comes in this function. Watch it. First call to that particular function. Only one copy of the function will be loaded in the memory. Okay. Become here. Print ascending is a function. Counter value is 1. 1 less equal to 5. Yes. Counter it prints as 1. Watch it. Counter becomes counter plus 1. 1 plus 1 is 2. Goes back. 2 less equal to 5. Yes. 2. It becomes 3. 3 less equal to 5. Yes. 3. It becomes 4. 4 less equal to 5. Yes. It prints 4. It becomes 5. 5 less equal to 5. Yes. It prints 5. It becomes 6. 6 less equal to 5. False. And return. And we come back. Now, this is not understood unless we don't see what's happening in the memory. So let me take you to the tutor or the Python interpreter. Here we go. Same function and same call. See the impact so that you can compare. Because how much ever I tell you, unless you don't see it visually, it's very difficult for the people like you, new people, to believe. So let's see the visualizer, what's happening. We are over here. The function is being loaded in the memory. Look at that function has been created. There is a reference to that function. So point is the function definition is loaded in the memory. There is this print ascending is only an identifier identifying that function which is loaded in the memory. Now we come forward. We ask the user to enter the number. User enters a number like 4 this time around, suppose. User enters number like 4. Okay, we come over here. We say print numbers in ascending order. And here we go. Enter the number 4. Print numbers in ascending order. So in the global frame, that is your function main, we have this identifier which identifies the function stored somewhere in memory. I remember I have been saying variable names are also identifiers and function names are also identifiers. Variable names identifies where the data is stored. Function names identify the location where the function is stored. The functions in Python are objects. They are stored somewhere in memory. So function name is just an identifier identifying the location where the function has been stored. Now here is line number 12. We are giving a call. Watch this very carefully. I gave a call to this function. So this function, copy of the function gets loaded in memory. First, we had one frame. Frame is like the instance of a function. One copy of the function has been loaded. Now, one instance has got loaded. That's on the stack. And stack is the memory area where the copies of the function gets loaded. So we have this function called as print ascending that you can see on the screen that has been loaded. It has one variable called as limit over here. Okay, one variable. Then it has one another variable called as counter. But have you noticed limit has got value 4? Where did this 4 come from? On line number 12, you pass num. Num ka value is 4. That was the argument, and that has been received in this parameter called as limit. So 4 has been received. Now we have a local variable called as counter. One more variable has got created. So all the variables that you define inside the function will be stored inside this frame. Mark my word, will be stored inside the frame. All the local variables that are present inside the function, the function frame, the frame, you could use the word frame. I'm using the word frame. I'm used to, I come from C background, so that frame comes to my mind. You can say activation record, that's the same. You can say instance of a function. Java people will call it instance of a function. Everything is same. So this is the first instance of a function called as print ascending. It has been loaded in the memory. What does it contain? Well, these are only basic things that you get to see. There is more that is there, like where does the function should return, where was it called from, all those addresses and everything is there. But that's out of scope for us. At least look at the variables. So there were 2 local variables inside the function. Yesterday we discussed function parameters are also local variables. So this limit and counter, these are 2 local variables which are there inside the function. Both of them have been loaded in the memory. So there is one copy of that particular function. Same variables will be used throughout the code. Watch it. I say counter 1 less than 4, yes, it prints counter, counter becomes 2. 2 less than 4, yes, it prints 2, it becomes 3. Can you see? It has become 3. It has already printed 2 here. If you can see this, it has already printed 2. 3 less than 4, yes, it prints 3, it becomes 4. 4 less than 4, yes, it prints 4, it becomes 5. Note, counter value has become 5. Counter value has become 5. 5 less than 4, condition is false. Condition is false, we come out, we say return. Moment you say return, this frame will get destroyed. So, point to be noted is, moment a function is called, a frame is loaded. What does that frame contain? It contains all the local variables which have been defined inside the function, plus some additional information which enables that function to interact with the environment. So I'm not talking about those return value, return addresses, but there are additional things which are there. Now, when I say return from this code, see what happens to this particular frame. So here I say, it says return value, kuch nahi hai, you are returning none. By default, dekho yahan none bhi hai. The return value is also there. Likewise, return address is also there, because the function should know where should I return this particular value none. It should return this value none exactly to the same place from where it has given a call. Okay, so it has to know the return address as well. This visualize is not demonstrating that. Okay, here we go. Moment you come out of that function, return from the function, that frame is destroyed. So calling a function is a costly affair. Last time when Ashish was using that recursive function very often, in almost 2-3 codes he used it, I said calling a function is a costly affair. So please understand why is it a costly affair. Because every time you call a function, a copy or a frame or an activation record has to be created. That's nothing but an instance of a function. That means copy of the function. Copy doesn't mean the code. Copy means a copy of all the variables which are present inside the function will get loaded on the frame. Which frame? Stack frame. So functions are allocated memory on the stack. Stack is a memory area. Okay. So the moment you give a call to a function, some provision has to be made in memory. Okay, now I need a memory for this particular function. Likewise, when you define a variable, memory is allocated for the variable. Likewise, when you call a function, memory is allocated for the function as well. Remember, while you are running a program, both occupy space. Variables also occupy space, and memory and instructions also occupy space. So function is nothing but a group of instructions with a name. Function is nothing but a set of instructions which have been given a name, which you can call. But you are going to call, that means it has to be stored somewhere. So when the moment you give a call to a function, a frame of the function gets loaded on the stack. So we call it as stack frame. Okay, your main was a global frame. And now when you give a call to the function, one more frame gets loaded onto that particular stack. What does the frame contain? Oh, it contains all the local variables. It contains the return value. It contains the return address. And all housekeeping information is there. So frame is created. It is initialized properly. But the moment you return from the function, the frame has to be destroyed. And allocation of memory for the function, deallocating the memory for the function, that's the costly affair. It doesn't take time to execute the instructions inside the function. Calling function is a costly affair because the moment you call a function, activation record needs to be created. Memory needs to be allocated for the storage of the function. Then function needs to be stored. Variables needs to be initialized. And once you're returning from the function, it has to do the cleanup operation. Memory needs to be released. The stack frame has to be popped out from the stack, removed from the stack. So that's going to be a costly affair, time consuming affair. So wherever possible, avoid calling functions. But then for decomposition, we need to use functions. You need to have a balance between them. So as far as performance goes, calling too many functions will have an adverse impact on the performance of your application, because calling function is a costly affair. Moment you call a function, keep in mind, memory needs to be allocated for that particular function. Variables that are local variables which are present inside the function have to be allocated some memory. Local variables, moment you return from the function, those variables needs to be cleaned up. That memory that is allocated for the function, that's activation record, that needs to be destroyed. So function calling is a costly affair. And we just saw that frame being created and frame being destroyed and so on. So that's one reason. But then what happens when I write a recursive function? We use a loop over here. So to run the program 5 times or 4 times, only one frame was required. Within one activation record itself, we could continue because we use a while loop, and that iterated over that particular counter is going to limit. It just went on. When counter became 4 or 5, it just terminated the loop and it came out. So to execute that particular code n number of times, you did not require n number of frames. Rather, you required only one frame within which the value of the variable kept on changing. So you did not create number of frames. See, now we are going to solve the same thing by using in a recursive technique. Now here, I'm going to do the same operation by using recursive. I say print ascending rec, a recursive call to the same function. Note there is no loop, but there is a conditional block. I told you every recursive call, that means over here in this code, I'm giving a call to this particular function. Oh, where has this call been given from? This call has been given from within the same function. So if there is a statement within a function which calls itself directly, that's a direct recursion that I'm using. I'm using a direct recursion. But this recursive call has been given from within the conditional block. So when this condition becomes false, if num not equal to 1, that condition becomes false. Okay, false. But that means when number becomes 1, we'll stop making this recursive call. Otherwise, it will become an infinite loop. I'll discuss how. Let's have a look at this function called as print ascending rec. What's happening? I'm going to call this particular function. I'm going to paste it and replace the frames that we had earlier. I'm going to stop this. Stop. I don't see stop. I'll say edit this code. I'm going to get rid of this. I'm going to print it over here. I'm going to give a call to this function instead of the previous one and see what is happening in the memory. Then later I will show you pictorially what is happening. Here you go. We start with visualization. We are at line number 1. That will just declare that function load in the memory. So the function has been created. Function name is just like an identifier, which identifies the function. Look at this object. It says in Python, everything is object. Even the function that's loaded in the memory, that's also an object. Okay. Now here we go inside the main block and we ask user to enter the number. User enters number like 4. I'm just keeping simple 4. And number user is entered 4. We say the numbers in ascending order are, and we give a call to this function. Watch it very, very carefully now. Print ascending rec is a reference to a function which is declared and kept somewhere in the memory. That's just a declaration. Now function has not been instantiated. Copy of the function has not been created. It will get created when you call a function. Line number 10, I give a call to the function. Note, moment I give a call to the function, a copy of the function has got created. Our activation record has got created. Luckily, there is only a single variable inside this function that has received value 4 because you have passed over here value 4. So 4 was received and I check 4 not equal to 1. Yes. And I give a call to the function once again. Moment I give a call to the function, another copy of that function will get loaded in memory. Watch it. One more copy of the same function has got loaded in memory with numka value as 3. Because over here I'm passing number -1. First time I passed 4. 4 minus 1 is 3. Then again we come inside. We check 3 not equal to 1. Yes. So we say print ascending 3 minus 1. That is 2. One more copy of the function has now been loaded in memory. Again we check 2 not equal to 1. Yes. So 2 minus 1, 1. One more copy of the function has been loaded in memory. So we now have 4 copies of the function which have been loaded in memory. Number value is 1. So we go inside. Is 1 not equal to 1? Condition is false. 1 is equal to 1. Then I go here and say print number. Now, moment I say print number, in the current frame, which has been marked as gray over here, the value of number is 1. So number 1 gets printed. Oh, note kijega, yahan number 1 has been printed. Then it returns. The return will transfer the control from the place where it was given a call. So this frame was given a call from here. I'll demonstrate in a different way also to you. So it comes back. Now it prints 2. So it comes to this previous frame. Now it will, in the previous frame, the control comes to the next line because this line has got executed now. So it will print 2. Then we return. The moment you say return, you will come to the previous frame. That will return, print 3 and return. Then we'll go back to first frame and it'll print 4 and then return. Look, 1, 2, 3, 4 has been printed without using loop. Now to help you understand this example even better, let me start with my, what's the board, Microsoft board? What do you call that? Whiteboard. And I'm going to take the same code. I'm going to just visualize it in a different way to help you understand the concept. So this is an example that we haven't currently talked about, print ascending rake. Say user passes number 4, first call. You received got number 4. We check 4 not equal to 1. Because our code says number not equal to 1, number ka value is 4. 4 has been passed for the first time. So 4 not equal to 1, yes. So we go inside, we give a call to print ascending rake. So control comes over here. So from this line, print ascending rake, we have given a call. So control comes over here and we come to print ascending rake where 3 has been passed. Why 3? Because you said number minus 1. If number value is 4, 4 minus 1 is 3. So 3 has been passed. Again, we check 3 not equal to 4. I'm just substituting the value because it has parameter has received value 3. So I'm saying 3 not equal to 4, 1. 3 not equal to 1, yes. So we say print ascending 2. 2 cube, 3 minus 1, a number minus 1, 2. I came over here. Print ascending rake 2. 2 not equal to 1, yes. I give a call to print ascending rake of 1. And here, 1 not equal to 1, condition is false. If the condition is false, we will not enter inside this if block. I'll say print 1. 1 has been printed and a function always returns to the place from where it was given a call. This copy of the function was given a call from here. So the control return transfers the control back to the place where the call has been given. Control goes here. We say print 2. So 2 has got printed. After print 2, we say return. So pehla 1 print hua. Control goes back to the place where the call has been given. Print 4 and control back to your name. And that's how it is printed the numbers in ascending order. Have you understood this particular concept? Quick feedback. Yes or no? You should. Okay. Now we saw one example. Let me take another simple example. It's not that straightforward. So we'll take one more example. I have print descending. Oh, we printed numbers in ascending order. Now I'm going to print the numbers in descending order. So to print the numbers in descending order, instead of this, I'm going to give a call to print descending non-rec. Okay, I'm going to give a call. So what is the number that you entered? Let me stop this debugger. And here we are on this line. We will print this number in a way. So I'm just going to debug this code. Watch it carefully. What's happening? We're here. Where are we? Where are we? Where are we? Okay, let's see. Where are we? Oh, we are not. Oh, it says enter the number. Here we are. So I enter number like 5. Huh? We have entered number as 5. I did not save it out. Let's stop and debug it once again. We enter number like 5. We are at line number 53. We give a call to this function print descending non-rect num. Num ka value is 5. We are given a call for the first. Here we go. Start will now have value is 5. Look at this. Start is having value is 5. Your number is value 5. That value of number is assigned to start. The start has value 5. So we print a message saying numbers in descending order are as follows. Okay. Starting from so and so are. So I say start greater than equal to 1. Start value is 5. Is 5 greater than or equal to 1? True or false?
True.
True. So it goes inside, it prints start, that's value 5. So note kijega yahan value 5 has got printed. And then we say start equals start minus 1. 5 minus 1 is 4. We go back. 4 greater than equal to 1, yes. We print 4, it becomes 3. 3 greater than 1, yes. We print 3, it becomes 2. 2 greater, look at this, it has already become 2. 2 greater than equal to 1, yes. We go inside, we print 2, it becomes 1. 1 greater than equal to 1, condition is false. Condition is true. We print 1, it becomes 0. Look at this, it has become 1 here. And when I say start equal to start minus 1, it becomes 0. So it is already printed 5, 4, 3, 2, 1 has already got printed. And after that, we check is 0 greater than 1, condition is false. If the condition is false, we come out and we say return. The return will transfer the control back to the place from where the call has been given. We have been given a call from here. Control has gone back exactly to the same place. Mark kijiye. Now what I'm going to do is, just to help you understand again, I'm going to ascending, descending. I'm going to do a debugging for this code once again in the visualizer. What I want you to have a look at it is how many frames are getting created. So non-recursive function, however large, only one frame is getting created. So it doesn't have to create copies of the function every time. Watch it. This function definition is ready. We ask user to enter the number. User inputs a number like 4. We go inside. And then we give a call. Okay, we are at line number 11. We print a statement saying enter the numbers in this ascending order. Oh, I should change the message. Let it be. Oh, I have given a wrong call. So I need to stop. I have to call this function. I call this function and it's not ascending, it's descending. And we need to visualize the code. Now I'm going to visualize the code from this line. Okay. Here we go. So we enter the code block. We have been asked to enter the number. I enter number like 4. We are at this line. We print the message. The numbers in descending order are, we give a call for the first time. This was the global frame, which has a reference to a variable called as number. It also has a reference to a variable, function identifier called as print descending rect. That's just a reference referring to the function, referring to a function. It's like the definition of the function. Moment you give a call, the copy of the function will get created. Its instance will get created. Like आपका design है, design पे variable function create होगा. Watch it. One function has got created. A frame has been loaded. Now we have variable start. Only one variable start, which has received value 4. So we check. Okay, we go inside and we print a message saying numbers in descending order are. Yeah, message print कर लिया. Numbers in descending order starting from 4 are. Start get equal 4 get equal to 1. Yes. We print 4. It becomes 2, 3, 3 will go 1. It prints 3, it becomes 2. Can you see 4, 3 has been printed? Then 3, 2 greater than equal to 1. Yes, it prints 2 and it becomes 1. 1 greater than equal to 1. Yes, it prints 1, it becomes 0. Look at this 4, 3, 2, 1. 0 greater than equal to 1. Condition is false. We say return. But have you noticed there is only one frame where the value of start has now become 0. Moment start became 0. We returned, we came back. Moment I say return, this frame will get destroyed. So only one frame has been created in the entire course. But suppose if I had done the same thing by using recursion, the story would have been totally different. So suppose instead of a non-recursive code, I'm writing a recursive code. Okay, not this one. That's not recursive. I'm going to write a recursive code. That's the code that I'm going to write. First, let's run this particular code to see the behavior. We're going to run this code from here. I'll stop the previous debugger. We are at line number 54 now, from where I'd like to start debugging this particular code. Watch it very carefully. We have been asked to enter the number. I enter number like 4. Watch it very carefully. I'm at line number 54, from where I give a call. We come inside the program at line number 41. We check, we print the number first. Last time while we are going back, we are printing. Now while moving forward, we will print the numbers. We first print the number, that's 5 will get, 4 will get printed. 4 not equal to 1, yes. Now we give a recursive call. Print descending rect, 4 minus 1 is 3. And now the control will again go back over here. Watch it. Let me run the code. I pressed the wrong button. Here we go. Enter the number. I enter number like 4 once again. Print ascending rect. Let's jump over here. And we check. Print number. So it will print the number. Number not equal to 1. 4 not equal to 1. Yes. 4 has already been printed. 4 not equal to 1. Yes. We give a call to print descending rect. 4 minus 1, that is 3. Look at that. Now number has value as 3. And we check. Print 3. So first 4 was printed. Now 3 has been printed. 3 not equal to 1, yes. It gives a call to print descending 3 minus 1. 3 minus 1 is 2. So we come here. Look, number has value 2. Again, we go inside to print 2. So we already printed 4. Then we printed 3. Now we have printed 2. And we check, is 2 not equal to 1? Yes. 2 is not equal to 1. We print 2 minus 1, that is 1. Oh, sorry. I mistakenly went over here. Actually, we go here once again. 1 not equal to 1, yes. We print number 1. 1 not equal to 1, yes. Then after that, number becomes number is okay. We have printed 1. Number value is currently 2. I just printed what I just clicked on the wrong button once again. So let's trace this code once again for you to understand this better. I have been asked to enter the number. I enter 3, 4. Here we go. We come inside. We print number. We have printed number 4 and 4 not equal to 1. Yes. We give a call to print descending rec. Watch it again. Here number ka value is 3. We go inside. We print number 3. 3 not equal to 1. Yes. We give a call to this function once again. 3 minus 1 is 2. So note, yeah, number value is 2. 2 not 2. We print 2. 2 not equal to 1. Yes. We give a call to the function 2 minus 1, that is 1. Here we go. Look at this 1. And then we'll print this particular number 1. 1 not equal to 1 condition is false. So we say return. Now note कीजिएगा यहाँ number का value क्या है? Number का value currently is 1. The moment I say return, watch it. From the first frame when I return, I go back to the frame where number ka value is 2. Then when I return, I go back to the frame where number ka value is 3. Then when I return, I go back to that frame where number ka value is 4. And then from there, I come back to your main. Now to understand this better, visualize it. Visualize this. That's the best way to understand it. ये non-recursive था. Now we'll go to the recursive code. Let's keep this thing over here. That's recursive code. And down rec. So the only word that I should get rid from here is non. Let's start debugging this code once again. See what's going to happen. Huh? And how are we very intelligently using this concept? Like either print before or print later. So one is non-recursive, other is recursive. So there are two functions now. One is pointing to a function called as print descending non-rec. Other is pointing to print descending rec. Both of them are function objects. Watch it. We ask you to enter number. User enters number like 4. Good. Here we are. Here we are. And we print this particular statement. So here we have printed enter the numbers in descending order. We give a call to this print descending rec num. That is where we are giving a call. What I'll do is I'll just get rid of this function so that we can see the entire screen. The screen is too small for us to display. Let's visualize. Here we go. So there's only one function print descending rec. Then we have a variable called as num. I enter value 4. We say the number in descending order are. We give a first call, watch it, print descending rec, and we pass 4. Now, moment you come here, one frame has got loaded where n ka value is 4, number ka value is 4. Watch it very carefully. Yeah? We print the number. Oh, last time while coming back, we have print. Now, while you are going forward, you are printing. We are printing number 4. 4 not equal to 1, yes. We give a call, a recursive call once again. The value of number currently is in this frame is 4. Watch where in this frame, the one that is being marked gray. Is frame में हम लोग उसका value number 4 है. So 4 minus 1 is 3. So we are giving a call to one more function. Note one more frame has got loaded where number ka value is 3. Again we'll check. We'll print 3. 3 not equal to 1. Yes. We give a call to 3 minus 1. 3 minus 1 is 2. So one more frame has got loaded. We print 2. Watch it. 4 3 2 has got printed. 2 not equal to 1. Yes. We give a call where number ka value is 1. Watch it. Number ka value has now become 1 in this frame. But just to print numbers from 4 to 1, we have to create 4 frames. Had it been 400, we'll have to create 400 frames. Had it been 4,000, we'll have to create 4,000 frames. That will not happen with a recursive code, non-recursive code. Here we go, we print 1. Watch it. 4, 3, 2, 1 has already got printed. 1 not equal to 1, condition is false. Watch this very carefully now. Here I say return now. Now, moment I say return, control will be transferred back to the place where the call has been given. This particular frame, whose num ka value is 1, has been given a call from this frame. So control from here will be transferred to its calling routine. Watch it. Here I'm returning. I go back to the frame where number query is 2. That's the current active frame. Then when I say return, it goes back to this. This is the calling routine. Then when I say return, it go back to the previous one. Then when I say return, it go back to main. ये आपका जो main and if name equal to main. But in the process, we have printed number like 4321. Even to understand this design properly, let's have a look at the design. What's actually happening? This is our function print descending rec number. We're going to first print the number. We're going to check whether number is not equal to 1, and then we're going to give a call to print descending rec number minus 1. That's the actual function. Here we come. First time user passes number as 4, so I receive 4. We print 4. After printing 4, we're checking 4 not equal to 1, yes. So we are now saying over here number minus 1. Na? So 4 minus 1 is 3. So we are now giving a call to the copy of this particular function, where the value of this particular variable number is 3. So when I give a call to this, it comes over here, it receives 3. When you print 3, we check 3 not equal to 1, that's true. And then we give a call to print descendant of 2. So we go here, 2, print 2 first. Then we check 2 not equal to 1, that's true. We give a call to print descendant of 1. So we come over here, 1, print 1, 1 not equal to 1 condition is false. So we stop the recursive call. We no longer make a call to this print descendant of 0. So we say return from here. The moment you say return, we control comes over here. After that, the next statement is return, control comes over here. After the next statement is return, control comes over here. And then we return back. But in the process, we have printed 4, 3, 2, and 1 has already got printed. So that's how recursion works. But every time you give a recursive call, one more copy of the function gets loaded in memory. So more and more activation records, and every record or every frame will occupy some space. So amount of memory that is required to run recursive code will just go on increasing as the depth of the recursion goes on increasing. So have you understood how recursion works, everybody? Very simple code, but my warning to you, for printing numbers in ascending or descending order, never in your life should you use recursion. I'll show you the problem also. Yes, Abhiraj.
But sir, those frames were getting destroyed, no, when we use return function.
Correct.
So then space was not utilized, no.
How is it not utilized? It is getting released only when we are returning. But till the time we do not reach that return point, is it not occupying a lot of space?
Sir, only till we are not returning.
Yeah, till the time you don't return. So there will be time when almost entire memory can also be utilized.
Yes, sir.
Okay. And that's precisely what I'll demonstrate now, how the recursion really fails. And this is definitely the direct recursion that we have been talking about. I haven't taken an example of indirect recursion because that's not that useful. That's actually more confusing and not recommended to be used. So we have used direct recursion over here. But in both these examples, we did not return any value. Let me take one more example for you to really get hold over this concept of recursion. So this was the simplest example that comes to my mind when it talks about recursion. Let me share this file with you all first. That's function recursive 1. Let me know if you have received this file now, everybody.
Yes, sir.
Let's take one more example. We're going to talk about a function called as factorial. We all are aware as to how to calculate factorial of a number. Let's first call this particular function where we have a non-recursive call to this particular function. Watch this here. I debug this code. Watch it. I ask user to enter the number. User enters the number. Say user enters the number. Oh, let's stop that previous debugger. For some reason, there is an issue. So we will have to start the, okay. Let's start with the debugger again. We are at line number 28. We ask user to enter the number. User enter the number like 4. We are interested in calculating factorial of 4. So we are giving a call to non-recursive function. Get factorial non-rec, and I'm passing the number 4. Here we go. Watch it. We come here, and we have discussed this function in detail earlier. So I will not spend time. We have variable called as factorial value is 1. Your number is 4 that you have passed. 4 greater than 1, yes. The factorial is a factorial number. 1 into 4 is 4. Number minus 1 is 4 minus 1 is 3. 3 greater than 1, yes. So 4 into 3 becomes 12. Watch it. It has now become 12. Number minus 1, it becomes 2. 2 greater than 1, yes. Factorial is right now 12. 12 into 2 becomes 24. Number becomes 1. 1 greater than 1, condition false. We return 24. Note that I have value 24 here. Only one frame has been loaded, and that value 24 has now been returned, and we print the result. Factorial of 4 is 24. Now, what I'm going to do is, I'm just going to copy this particular code and again do the same thing. Visualizer. That's the best way. 3 चीजें करने वाले हर जैसे. We'll visualize, and then after visualization, we'll see the diagram as well. This is a function that we have. Let me get rid of this blank line. Here we go. Let's visualize. Visualization, because this frame is going to have more than one variables. Watch it. The function definition gets created. In the global frame, we have this reference that's identifying this particular function in memory. We go inside. We ask you to enter number. User enters number like 4. Here we are. We give a call to function get factorial non-rec. We pass 4. Watch it. One frame has been loaded. It has number 4. That's the function parameter. It will have one more variable called as factorial, whose value is 1. Okay. Number greater than 1. Yeah. 4 greater than 1. This 4 greater than 1. Yes. So factorial is equal to factorial into number. 4 into 1. 4 into 4. Number is 4 right now. So 4 into 4. Factorial was 1. 1 into 4 is 4. Number is number minus 1. So 4 minus 1 becomes 3. 3 greater than 1. Yes. Factorial value 4 hai. So 4 into 3 now becomes 12. Number is equal to number minus 1. That becomes 2. 2 greater than 1. Yes. So 12 into 2 becomes 24. Look at the factorial value 24 बन चुका है. Number is number minus 1. That becomes 1. 1 greater than 1. Condition is false. We come inside. We return factorial. A factorial value 24 है. That will now be the return value. Because return value में 24 आ गया. Because I'm saying return factorial. It's not the variable that is returned. It's the value of the variable that is returned. And where is it returned? To the place from where the call has been given. Call has been given from line number 12. So control has gone over here. Line number 12. Factorial के variable में यहाँ 24 store हो चुका है. And then we print the value factorial. So it says factorial of 4 is 24 has been successfully printed. Now, this was non-recursive code, which we have already discussed in the earlier sessions of functions. Let's have a look at a recursive code to get the same work done. And then I'll also visualize this. After visualization, we'll see the memory as well. See the diagram also. Here we have get factorial rec function. So I'm going to start visualization. Watch it very, very carefully if you really want to understand this concept. The function definition is already there in the memory. We are asking the user to enter the number. Again, user enters number like 4. Okay. We give a call to function get factorial num. Num का value is 4 right now. Note कीजिएगा यहाँ num का value is 4 in the global frame. We give a call to get factorial 4. Here we go. We come into this particular frame. In this frame, number ka value is 4 right now. Okay, and then we check. Is 4 equal to 1? Condition is false. Okay, condition is false. 4 equal to 1, condition is false. So we go to else part. And what do? We say number whose value actually 4. 4 into get factorial of num minus 1. Arey, what are we doing over here? Unless this function does not return value, this statement will not get executed. So we are stuck over here. So let me show it with the help of a diagram to you. And then I'll continue this execution. Watch it. This is an example that we have been talking. You pass suppose 5, 4 की जगह 5 pass किया आपने. 5 equal to 1 है क्या? नहीं है. We go to else part. We say 5 into get factorial of 4. So when I say get factorial of 4, it is calling another function. So it will load another function. And here value of that number is 4. We'll check is 4 equal to 1? Condition is false. So we say return 4 into get factorial of 3. So from here I'm giving a call to another copy of the function. And we say is 3 equal to 1? False. So we say 3 into get factorial of 2. Here we go. Is 2 equal to 1? False. We say 2 into get factorial of 1. Again, we go back here. Is 1 equal to 1? Yes. So from here, we return 1. So this 1 will be returned to the place where the call has been given here. So 2 into 1 becomes 2. That gets returned over here. So 3 into 2 becomes 6. That is now returned to its caller. And 6 into 4 becomes 24. And that's returned to your caller. And 24 into 5, that becomes 120. And that is returned to the main block from where that is going to call. So when this statement will not get evaluated, executed, till it's like 5 into some value. That some value I should get. But I'm going to get this value only when the function returns. So till the time the function does not return, this statement will not get executed. Okay, and the same thing has been demonstrated in this visualizer as well. So please watch. Here we are. We are saying return number into get factorial. Number value 4 hai, and that is to be multiplied by get factorial of 4 minus 1, that is 2. But then this has to get solved first. So watch what happens. One more copy of the function has got loaded where num ka value is 3. And we check. Is 3 equal to 1? False. Return 3 into, so this 3 number is 3, 3 into get factorial of 2. So one more frame will get loaded. And say, is 2 equal to 1? Condition is false. Return 2 into get factorial of 1. Here you go. 1. Is 1 equal to 1? Yes. And now I'm going to say return 1. This 1 will be returned in this frame. Jahan number ka value 2 hai. And they will multiply 2 with 1. Watch it. Return value dekho, 1 hai. That will return to the previous frame. So 2 into 1 becomes 2. That will return to its previous frame. Okay. 3 into 2, that becomes 6. 6 has been returned. 6 will now be returned to the previous frame. And that becomes 6 into 4 becomes 24. And that will return to your main block since we had passed number 4. So that's how this recursion really works. Did you notice? For every pass, for everything, one more frame gets loaded. So if the number of frames goes on increasing, there's always a chance the program may crash. Have you understood this, everybody? Yes or no? Okay, what I'll do is now, I'll share this two example that we have taken. Function recursive 2 is the name of the function. Function recursive 1 we saw, and function recursive 2 is the one. And I'll also share with you all the whiteboard. Let me know if you have received this whiteboard as well. Yes or no?
Yes, sir.
So do download, have a look at it. That's how recursion really works. But how are we going to stop over here? Definitely not. There is more to this concept of recursion. But before I proceed further, there's a small piece of code that I want you to write. Let's understand why recursion are a risky matter. Okay, why recursion is a risky matter. So what I'm going to do is I'm going to write a recursive code and a non-recursive code. Okay, watch it. Here you go. Watch this very carefully. Yeah? I have a function called as countdown. Okay, that's the function name. Function name is countdown. And I pass number 10 to this particular function. I'll comment out the next one. Countdown 10. So what will happen? You receive number 10 over here. 10 greater than 0, yes. It'll print 10. Sleep for 1 second. And 10 minus 1 becomes 9. 9 greater than 0, yes. So it's going to just print on like countdown for 10, 5, 4, 3, 2, 1, and 0. The blast off. Rocket will fly. Let's see. So 10, then 9, then 8, then 7, then 6, then 5, then 4, then 3, and then 2, and then 1, and then blast off. Oh, fine. Now, what's so special? We know how to print numbers in descending order. So there's nothing special about this. What has been opened? So let's keep this thing aside. Nothing special. I could do the same thing by using a recursive code as well. How could I do that? Here you go. We want to blast till 10. Here we are. There is a recursive code. And look, there is no loop now. I say if number greater than 0, we print the number. We print the number. After we have printed the number, I'll again put it as 1 second only for a moment. Sleep on. After we have printed this particular number, I'll suspend the operation for 1 second and give a call to this function once again by number -1. So 10 minus becomes 9. So another call with 9. 9 greater than 0, yes. Then 8 greater than 0, then 5, then 4, then 3, and then 2, and then 1, and then because 0, conditions false. So it will just keep on returning. So let's run this particular code and see what is happening. Watch it. 10, 9, 8, 7. It's working exactly in the same fashion. So what's the difference? Viraj was arguing here saying, "Arey sir, वैसे भी return करते समय memory free हो जाएगी." Okay, let's do something more now. I'll reduce this speed. I'll just make it work faster. I'll say 0.1. Okay, sleeps 10, 0.1. So there are fast काम करेगा और कुछ नहीं. Let's run the code once again. I run this code. It is printed. You must have seen 10 to 1 print कर लिया, blast off. Great. So let's do it non-recursively. But this time around, number is not 1, 10, it's 1000. So 1000 times I would like to run this particular blast off till 1000. So ये चलता रहेगा. Meanwhile, I'll drink water. That will take too long. What I'll do is I'll probably stop. Okay, let's stop. And let's improve the speed. थोड़ा और fast कर लेते हैं. इसे कहते हैं 0.01. Okay, that's too fast. But let's run. It's only one frame, single frame, and blast off. Great. What's so special? 10 से print किया क्या? 1000 से print किया. Now let's ask the recursive function to do the same thing. 1000 से print करो, recursive function. Let's stop. Let's increase the speed first. It was too slow. 1 second कहा, 1000 second थोड़ी wait करेंगे हम लोग. I say 0.0 second. Okay, we're just increasing the speed. Let's save this file and run it. Run किया जा रहा है. Let's see. Point is, every time you give a call, one more frame is getting loaded. Huh? तो उतने सारे frames load होने वाले मिल रहे हैं. Oh, you're lucky. It has got executed. Okay, we are lucky that has got executed. Let's increase this particular number that we have here to 5000. And let's see what happens. It is crashed. It did not complete 1000 recursions. It did not go till blast off. The program got crashed in between. Okay, the program has got crashed. Why? Because so many, क्या कहता है, maximum recursion depth exceeded while calling function, while calling Python object. So it is not left with any more memory on the frame to create an instance of that function, activation record on that of the function in the memory. So it has reached a point where it is no longer having that additional memory to print or to load the function, copy one more copy of the function. The program has crashed. Here for 5,000, it has crashed. Here instead of 5,000, even if I had taken 10,000, yeah, 1 lakh. That's 1 lakh. No such thing would happen even if I take it 1 lakh. Recursive hai, non-recursive hai. Just one copy of the function. Here it has failed for even 5,000. Even before 5,000, somewhere around 3,000, it has failed. Because it printed till 3,000 means 2,000 iteration it has done. And it has crashed. And this will just keep on. Look at that. We already reached 10,000 iterations. 90,000 मतलब 10,000 तो जाएगा. ये आ गया. 3,000 हो चुका है. And जब 80 में जाएगा तो 10,000 iterations हो जाएंगे. And it will successfully print till 1. It will just keep on printing. Because it's just one frame. A recursive nahi hai, non-recursive. It's just one frame. Just the value of the variable is keeping on decreasing. So what I'll do is I'll increase the speed even further by removing this clip over here so that we'll just quickly get the answer. Watch it. It will not, definitely not crash. And you can scroll and see it's from 1 lakh. All the things. You can just keep on scrolling up. You'll get to see all the values that have been printed. Sare aa chuke hain. Everything printed. This will definitely not go to that level. Okay, so the program is getting crashed. Now, the other way to check this particular code is to run this program from the command prompt. IDs make certain things different. So let's run this code from the command prompt for 100 iterations. We are in this particular location. D-consist Python/programs. So I say d:/cd Python cd programs, and the name of the program is Python recursion 4. Function recursion 4. And we're going to print it 1,000, 100. 100 print हो गया. Happy? अगर 100 की जगह 1,000 होता, 1,000 iterations आपको प्रिंट करने हैं, 1,000 भी प्रिंट हो गए. देखिए ऊपर 1,000 से शुरू होगा. Believe me. 1,000 से शुरू हुआ. ये प्रिंट हुआ. ये नॉन रिकर्सिव था. Let's do the same thing for recursive. पहले 50 प्रिंट करके देखते हैं. प्रिंट किया 50 तक. Let's remove this time that we are suspended. And 50 का 500 करके देखते हैं. 500. Okay. What's so special? ये 500 कर लिया. 500 का 1,000 करके देख लेते हैं. Program is crashed. So we said 1,000, around 996 iteration has done. 4 पे आने पर रुक गया, यानी 5 अगले 4 के पहले memory it has fallen short of memory. कहता है maximum recursion depth exceeded, यानी in this particular thing where I was showing you first frame, second frame, ये जो depth है, first depth, second depth, third depth, ऐसे depth का एक limit है कि how many frames could have been loaded, and that limit will vary upon how complex that function is, how much memory that function takes. This particular function is having only a single local variable called as number, but there could be a function which has a lot of local variables. Amount of memory will be increasing. So depending on how much memory each, because your stack is limited, so amount of memory that every copy of the function takes, that will decide upon, that will determine how many such frames will get loaded in the memory. So now, if the depth increases, like when I gave 1,000, here even if I give 1,000, here if I give 10,000, then also there is no problem. Watch it. I give 10,000, non-recursive code. You print it 10,000, and don't ask me to go and check it out. Oh, 10,000 definitely hai. Upar jaoge, it will definitely be 10. Oh, let's not run here. Let's run here. So we can see all the things. Yeah. And if I scroll this up, you'll get to see 10,000 se shuru ho raha hai. Ye sara hai 9,001 se hote hue. Ye sara 10,000 blast off. And there's no way we could do it over here. Yeah, 1,000 mein hi nahi ho raha, 10,000 kahan se hoga? Here I go. Yeah, 2,000 kahan se hoga? If I try and do that, it is obviously going to fail. 104 pe fail hoga. So only that many number of iterations. Baki ka kya? It has failed. For any reason, you want to increase the depth. So I allocate more memory. Say import sys and say sys dot set recursion limit. I say 2000. Right now it has failed for 2000. Now I say set recursion limit as 2000. It failed at very early right now. कहाँ fail हुआ ये? 104 पे ही fail हो गया. Suppose अभी मुझे 1500 चाहिए. So I say 1500. Just set the limit slightly higher than the depth that you like to go. तो मैंने 1500 का depth लिया है, recursion लिया है. Successful हो गया. Why? Because I increased the recursion limit, the depth. But there is also a limit. You cannot go beyond the memory that is available. तो आपने यहाँ 2000 कहा है और आप यहाँ 2000 ही कह रहे हो. So would it work? Let's see. It has failed almost when it was near 2000. So let's increase the depth to 2500 and run the code. हो गया. So Python gives an opportunity to increase or decrease the recursion limit. I decrease the recursion limit to 500. And we only say 1000 time karna hai. We have increased it 1000 time karna hai. Let's see what happens and where it fails. So it has failed somewhere near 500 only. Only that many number of that depth it has gone ahead. Okay, so we can increase or decrease the depth of recursion. And that was the another part. Recursion alternative form of program to control loops. Essentially repetition without loop. Recursion program can run out of memory, causing stack overflow exception. That's precisely what we have seen right now. Avoid using recursion if you're concerned about program's performance, because it takes more time and consumes more memory than iteration, regular iterations. There's this function called a set recursion limit. Function is used to modify the default recursion limit set by Python. Using this, we can increase the recursion limit to satisfy our need. So I imported sys and I say sys dot set recursion limit as 500 or 5000, whatever it is. So that's what we can do to control the recursion limit. Have you understood this concept?
But sir, we did not write return, no, in recursion. If
Pardon?
we write, if you put return at the end, then will it be successful?
You write return at the end or you don't write return at the end. It's one and the same. The return is the implicitly the last statement in every function. हर एक function में last statement return ही होता है. आप लिखो या ना लिखो. यहाँ ना?
हाँ sir.
Let's say I'm writing. A return is such a statement that even if you forget, system is going to take it. Every function has to return. So even if I do this, limit is 500, I say return, it's still going to fail. Fail हो गया?
हाँ sir.
Return is implicit, automatically आ जाएगा. Every function, the last statement to be executed in every function is return. You write it, you don't write it. But then as you pointed out, it's a good practice to write return, not a compulsion to write return, unless you want to return a value. So when the function is going to return none, you may just not write it. It will still return implicit. It's implicitly the last statement in every function. Return is the last statement in every function. So that was about a recursion limit. Let me share this file with you. Anybody has any question, please ask. अगर ये टॉपिक आपको समझ में आ गया है ना, तो you should be very happy, because Python is not difficult than this. थोड़ा सा confusing ये topic. So if you are understanding this, you should be happy about your own self. एक assignment है हमारे लिए. What you are going to do now, next, you're going to check whether a given string or an integer or integer is a palindrome or not. What's a palindrome? And that too, I want a recursive code for it. So think about it. What's a palindrome? 121 is a palindrome. Because if I read it from left to right or right to left, if I read the number or reverse of the number, it's exactly the same. So I want you to write a recursive code to check whether a given integer is a palindrome or not. So you're going to pass an integer. आपको सिर्फ return करना है true or false, saying, oh, it's a palindrome or it's not a palindrome. Return करना है true or false. Whether a given integer is palindrome or not. So that's what you are supposed to do. So take the assignment. Write a function is palindrome. Write a function is palindrome. that takes a single integer as its argument. And returns true if it's a palindrome, otherwise it returns false. Returns true if it's a palindrome, otherwise returns false. तो मुझे रिकर्सिव कोड चाहिए हाँ इसके लिए. हमने तो नॉन रिकर्सिव लिखा हुआ है, but I want you to write a recursive code for the same. Okay, just a passing reference to another concept called as tail recursion. It's a very common question, and it's a must thing that happens. If you answer during interview for any language, not just Python, most of the languages, if you answer the questions on recursion properly in the very first instance, okay, without any fumble, expect another question to be asked by the interviewer called as what is tail recursion. Because when we talk about recursion, we always talk about performance. Performance is bad, it gets hampered, memory is wasted, it takes more memory, it takes more time because calling function takes time. Huh? It takes more time. So recursions are not good. And then they ask, then how do you improve the performance of recursion? It's bad. Write a non-recursive code. But if I have to write a recursive code and I want it to work as much better as possible, then what? Then think about tail recursion. In traditional recursion, the typical model that you perform your recursive call first and then take the return value of the recursive call and calculate the result. What we did in that factorial function. We made a recursive call, the recursive call returned a value, and that we used to multiply with the previous value and so on. In this manner, you don't get the result of your calculation unless you have returned from the recursive call. So when I showed you this particular diagram, here, these two functions, there was no problem because they were not returning value. Over here, this statement cannot be completed till the time this get factorial rec of 4 does not return the value. What are you going to multiply 5 with? For you to multiply 5 with some result, so I should get this value 24. Or when will I get this value 24? Only when this function inside get factorial rec returns the result. So you have to stop till that time. That's the problem. In tail recursion, you perform your calculation first and then you execute the recursive call. Here, the recursive call is done within the calculation. In tail recursion, it says you do the recursion first, okay, and then you do your calculations first and then make a recursive call. Here, the calculation cannot be completed unless the recursive function does not return. In tail recursion, it says you perform your calculation first and then you execute the recursive call. That means, is this whiteboard visible?
Yes, sir. Yes.
So in this case, we are making a recursive call. When this recursive call returns a value, that will be multiplied by 5. So this statement has to wait till the time this function does not return a value. It says don't do that. You perform your calculation first and then you execute your recursive call, passing the result to the current step, to the next recursion step, and so on. Tail recursion function is efficient for reducing the stack size. How does it reduce the stack size? Say, suppose if I have 10 recursive calls, so that will be 10 frames. And from the last 10th frame, control go to 9th frame. 10th frame is destroyed. From the 9th frame, it will go to 8th frame. 9th frame is destroyed. And so on, it will go 1, 1, 1, 1 step. Why? Because whatever value that you're returning from the 10th step, 9th step requires it. Whatever value you're returning from the 9th step, 8th frame requires it. So the value that is returned by one frame, the previous frame requires it. So you have to return the value and then destroy this frame. Then this particular frame will return a value and then it will get destroyed. So on, you have to go back in the ladder. But then in tail recursion, that's not the case. The function is said to be tail recursive if there are no pending operation to be performed on return from the recursive call. So when you're going to return from the recursive call, you don't have to do some operation. After you have neither printing, nothing. So when you return from the recursion, you don't have to do anything. So in that case, we can use tail recursion concept. Okay, and what happens in that case? Say I am on the 10th frame, but after returning, I don't have to do any operation. So all those frames will get destroyed in one go. So it will not be the case. Rather, that many number of frames, some designs will not create that many number of frames, because after returning, you don't require the previous frame. So it may destroy the frame the very first time and just keep one frame in memory. So amount of memory that is utilized if I use tail recursion is far less as compared to amount of memory that is utilized when you're using a regular recursive function. So wherever possible, design a code which uses tail recursion instead of a recursion. Okay, I'll just show you an example for tail recursion. We have this function called as factorial. This function factorial calls another function called as factorial helper. Calls another function called as factorial helper. Watch it. It's a very powerful construct that I'm teaching. Many textbooks will not even talk about it. We are going to do it recursively, but tail recursive, so function works faster. And the amount of time it will take, the number of frames that will, so the depth will not create a problem for us. I have another function called as factorial helper. I pass number and 1. Oh, user passes only number 5, whose factorial he has to find. We call a function called as factorial helper. That helper will take 2 values, the number and 1. So once we come here and check, is number equal to 0? No, number is suppose 5. 5 equal to 0 nahi hai. So we'll say return factorial helper of, watch it, n minus 1. So 5 minus 1 is 4 into 5 into 4. So you're just going to return this value. Nothing. This return value is not going to be used in any further calculations. Okay, you're going to return result. What's the value of the result? Oh, you haven't given any value as the value of the result. Here, when I say num minus 1, that becomes 4. Initially, n was 5. So 4 will receive over here. And n into result, that's 4 into the value of the result that we had passed earlier, 1. Yeah, 5 into 1. So 5 into 1 is 5. So 5 will be stored over here. And then is 4 equal to 0? No. This will become 3. And this will be 4 into 5. That becomes 5 4s are 20. So 20 will be stored here. 3 will be here. 3 equal to 0? No. So in this case, it will be 3 minus 1 is 2. And 3 into 20 is 60. 60 will be stored here. And this is 2. 2 equal to 0? No. So 2 minus 1 is passed. And 2 into 60 is 120. 120 is passed. So here we have 1, and here we have 120. Okay. N equal to 0 can I? 1 minus 1 becomes 0. And 1 into 120 becomes 120. So n is 0 and this is 120. N equals 0, I can return 120. So the return value is not being used anywhere. We're just passing what you have to return is passed to next function, next call. So you are no more calculations have to be done while you're coming back. So the same example of recursive function for calculation factorial can be done by using tail recursion. And that will substantially improve the performance of using recursive code. So if somebody tells you write a recursive function efficiently, think about it in this fashion. It'll reduce the stack size. Let me just check whether that is demonstrated correctly by the visualizer. So even if the visualizer doesn't demonstrate it correctly, then the visualizer is not perfect. But what I said is correct. Somewhere you have to believe me. You do your own research. Here we go. We have this visualizer helper. We come here. We give a call to this function factorial. N is there. We have this function factorial. Oh, that was a non-recursive code. Oh no. We now give a call to function factorial helper. Here we go. And this helper, n is 5 and 1. Watch it. 5 and 1. N equals 0 can nahi hai. And we say return factorial helper of 4, 5. So 4, 5 is been passed. 4, 5. Actually, it will not waste its time creating these frames. Okay, it's just showing in a simple fashion. Let's see whether all frames get destroyed in one go. Is the visualizer visualizing it correctly? Let's see that. And last, n ka value 0, so it's a return result. it did not visualize it properly. That does not mean what I discussed is not right. Just that visualizer could not, was not that smart enough to do the optimization that Python does, or any other program. It will reduce the stacks. It will reduce the stack frames. So tail recursion function efficient for reducing stack size. We will not create a copy of that function every time, because the return value is not to be used in the यहाँ से जो return कर रहे हैं आप, that's not used in the previous call anyway. That's not used in the previous call. Or instead of saying return, suppose if I had said something like this, let's see whether this particular form will work. Okay, so it has worked. Oh, it's saying that profile is none, so I'll have to say return. Factor of 5 is 120. Now, just to talk about performance, let's go here. I have this recursive function and I have this non-recursive function. Just to calculate Fibonacci series. So I hope you know what Fibonacci series is. Where 0, 1, 1, 2, then 3, 5, 8, 13, and so on. So the point is, one is recursive, other is non-recursive. That's the point. And we know the time it module. So I'm going to time it for a non-recursive call and for a recursive call. Here I'm going to give a call to recursive function when n number is 10. Here I'm going to non-recursive call where number ka value is 10. So call is the same. I want 10 numbers from the Fibonacci series. I want the 10th number from the Fibonacci series. So call is same. Okay. Same with the same parameter, but one is recursive call, other is non-recursive call. So let's run this particular code from the command prompt. Program name is function recursive performance. So recursive version is taking how much time? We'll say time bit module, we already discussed it, so I'll not talk about it. So I want to find the 10th number, but here the number of times repetition is somewhere like 10,000, 1 lakh, 10 lakh. So the non-recursive took almost 10 seconds. Whereas non-recursive took hardly anything, not even 1 second. So it has got executed very, very fast. Recursive code takes 10 seconds. Non-recursive code has not even taken 1 second to complete this work. Both of them are doing the same task. So that's how better the non-recursive codes are. So when I'm talking about the performance, they will always work much faster than a recursive code. Wherever possible, go ahead using non-recursive code instead of using a recursive code. So let me share these files as well with you. And here you go. So I'm sharing both the examples with you. Have you received those examples?
Yes, sir.
Okay. So that was about recursion and the topic of recursion actually. Now what next topic is to be discussed are very, very advanced topics in Python. And most of the courses you will not find this topic even been touched upon. And believe me, if you try and do it on your own, it will only add to confusion. The next topics that we are going to discuss are iterables, the yield statement, the generators, and the closures. These are all new topics. And the best part is modern C++, Java, or the closures, they are now trying to replicate this particular concept in the languages. So languages are struggling, or they're wanting to have such kind of features. Every language designers are wanting to have this kind of feature in their language, and Python has it for a long time. So we're going to discuss some advanced concepts like generators and decorators and the yield statements, which are very, very advanced concepts, is what I'm going to discuss. So please don't miss the further lectures. Very important discussion what we're going to have. Just complete that one assignment that will give you a confidence of writing a function recursively. Your task is to print, check whether a given integer is a palindrome or not. And that too, you're going to write it. First, write it recursively, non-recursively. My own personal experience I'll share with you. I have never written a recursive code, without having idea as to how to write a non-recursive code. So if you feel like I don't know how to write a non-recursive code and I'll write a recursive version of it, 9 out of 10 times it will fail. If you have a recursive code first, and then you can eliminate that loop by using if condition and then giving a call to that function again. That's how I think, and that helps me. And that's an advice for you as well. So even if somebody asks you to write a recursive code, first try a non-recursive code. If you can do that, replace the while condition or the looping condition with a if statement. And to iterate, just make a recursive call. That's the simplest idea. Interviewers unnecessarily trouble you, forcing you to write a code in recursive fashion. Write a recursive code, non-recursive code, and convert that to a recursive code. And steps to do that is replace the looping condition with the if condition. And at the end of the loop, the controls goes back. So just make a recursive call over here, and that's it. So that's how simple it is to convert a non-recursive code to a recursive code. I hope you take this hint and get that work done for your assignment as well. On that note, we'll stop over here. See you next time. Take care. Love you all. Bye-bye.